Okay, yeah, here in this board file, by the way, it's board.h. This is where he had, or one area where he had a reference copy of this GFX in here, a cached copy, he called it. Now, you can see he has declared a local object as a GFX, which is a graphics type object. He calls it GFX here locally. He could have called it anything he wanted here locally, but it's a reference, because of this. Because normally you wouldn't put that, like inside a class. I mean, why would you know reference to a variable? Okay, but this has got a handle to it. Because again, he could just create an instance of a graphics object right in this class. Just like game.cpp, for example. Shit. God damn it. You fucking piece of shit. Okay, game CPP, we create all these instances of objects in here, and this is a class. So, we could have done the same thing here and created a GFX object, but then this program would have two GFX objects in it. We don't want that. So he's creating a cached copy right here, and this is where the magic happens. By having this object declared as a reference, then when he instantiates, the object through the constructor right here in board CPP, you can see that what he does is he takes that reference and passes it into this, so it basically copies this passed in GFX, which is our actual GFX object from the main code, which you can see. I assume that I passed it in over here. Let's see. I think I did. Which you can see right here, board GFX. So that's when the game object's created, it also creates this object, and it passes it in a reference to the GFX object, which it also instantiates, if I recall correctly. Yeah, GFX, which passed in a window handle right here. So the game object does instantiate GFX. And by the way, this order you see here is not the order it's executed. That these things are initialized. It is determined by the order they're listed here. This is what determines the order of initialization. It is irrelevant how they're listed here. So this has nothing to do with the order they're actually initialized. And that can be important, because sometimes you need to initialize some objects before others. So, like for example, if GFX wasn't initialized first, our board object wouldn't really get a valid reference, would it? So, but what determines that is that GFX is actually initialized here. Because it's actually instantiated here, and this determines the initialization order, not what you see in the game CP after the colon. So, but yeah, so this is basically, though, what creates the cached copy is this, and this is just a cached copy, but if there's ever a change, again, since it's still a reference, because we're actually setting it equal to, to our, we're setting our local copy, but it's listed as a reference, it's created as a reference. So because of that, we're not only copying, GFX to it, because again, if we didn't create it as a reference and we just had GFX and no ampersand there, this would simply make a copy of it to GFX. Our local GFX would have a copy of the global GFX, the true GFX object. But it would never be updated. But because we declared it as a reference, it's technically a cached copy. So it will create a local copy of it, but it's a reference. So if there's ever a change in GFX, it'll actually update this too. But it is a local object, so it's a local copy of that object, But this way, like I said, you know, in certain situations where you'd have to pass a GFX object in, you know, he doesn't have to because we got a local cached copy. So it's just less coding you have to do out on the other, you know, out in the field, so to speak. So, but like I said, you know, he needs, you know, he has to pass, like for example, the color object into here in a location, but you know, he's doing a draw rect dim, um, you know, which is a GFX object. So he's able to, you know, just go GFX dot draw, draw rect dimensioned or whatever, you know, whereas he would have to have that GFX object passed in otherwise, like he kind of does here, kind of. But because we got a local cached copy, he didn't have to do that, so we can just work with that copy. But like I said, the best time to create that ostensibly is, you know, in the constructor. But it will be a reference, so anyway, it's pretty cool. Yeah, and here's another example. You know, this meter function of his does not have a cached copy, and as a result, you know, he's got to pass in a reference to the GFX object. So when you call the draw function, you got to, you know, pass it in GFX too, so that it'll draw a rectangle, you know, using the GFX object that was passed into it by reference. So, you know, if you look at the game code over here, I'm sure, I think I still have it in here. Meter.drawGFX. Just like dude.drawGFX has to be passed in, and goalbox.drawGFX has to be passed in. It's not that big of a deal, but you know, hey, it's nice to not have to, right? It's kind of a convenience thing. I don't know if there's any kind of penalty for doing that, you know, because again, in theory, you know, okay, if every time the GFX object has some kind of internal change, it's going to update the cached version. You know, you had a lot of cached versions. It seems like that would be a lot of updating it would have to do. So I don't know. And if the thing was changing frequently, if you had like, you know, 1,000 objects and they all have cached copies of it, you know, what's that going to turn out to be? I don't know. I mean, maybe they all share a common copy or something. You know, you'd think they could, but I don't know. I mean, I don't know if that would, you know, lead to a lot of overhead or not, so I'm not really sure what to make of it as to whether I'd want to do that as opposed to just passing it in this way. So, I mean, again, if it's something you're not doing very often, it seems like that'd be okay, but if this GFX object changes in some way, you know, well, you know, that'd be maybe an issue. So I don't know. I don't know what would constitute a change and require an update, because I didn't have anything to do with creating the GFX object, you know, so, you know, because that's a graphics CPP thing, and you can see how involved that is. So this is all DirectX gobbledygook. So all this just to draw points. You know, that's all this really does is draw points in essence. So, you know, graphics, end frame, begin frame, put pixel. Here's where the put pixel. You know, that's what all this code's really for. It's just for this one little function. So, you know, this version of it, I don't even think has the draw rectangle function in it. So, or maybe it does. It might be in the .h. You know, the graphics.h file. I don't know. Let me go peek at it real quick. Okay. Put pixel, draw rect, draw dim rect. Yeah, so, you know, this just calls the draw rect, and, well, there must be some definition. Yeah, graphics.cpp, I guess I just didn't see it. this must be after the chili exceptions. Oh. Well, actually, let's go have a look at that. Go to definition. Alright, yeah, because this is something I was fucking around with. When I created this rectangle function, I put mine at the end of his exceptions, and his version he puts like here, he doesn't like putting things, he likes putting his exceptions at the end, which is fine. That's probably a good idea. But anyway, I went and defined this version because I wanted to test several things, because we have a swap function in here. And it was like, man, I know there's other ways of doing it than the way he did it, and I started thinking about it. It's like, there's got to be other ways of swapping variables. So anyway, I went in and defined all these different preprocessor directives, so you can choose whichever one of these you want to execute. They all do exactly the same thing, just in different ways. So they're just different swap functions. So right now we're using the chili version. So, let's say use temp. This uses temporary variables, so, it's a cumbersome way of going about it. But we can use ternary operators, so, we can do it this way. We can use addition method, so, I got a lot of this off the internet, because it was one of the little problems that was bugging me. I suspected it was possible to do it this way, as it turns out it is. But all these do is just swap, two variables if one is bigger than the other or whatnot. So, we swap x and xo and x1 and yo and y1 if and only if one is bigger than the other. So only if yo is greater than y1 do we do a swap on it, and this is a swap function. And only if xo is greater than x1 do we do a swap function here. So it kind of filters it out. But you can do exclusive OR, which is a clever way. I suspected this was a way of doing it too, particularly from assembly language, but it's been a while since I've done any assembly language now, so I'm a little rusty, but I figured it might be possible to use a logical bitwise version to do a swap, and it is. Because I've done that before, but again, it's been a while, so it kind of just gets fuzzy after several years pass. Anyway, and here's the long form of the exclusive OR. So there's a short form. So I just thought the long form is a little clearer from my perspective. Then of course we can use the swap function, so and the chili was, which chili ultimately did it this way, but initially he was doing it this way with this test and swap external function, so that you see here. So here's the original draw rectangle code, but problem is it won't draw a rectangle, with a mouse anyway. If you're off to the left, and if you're in like quadrant 2 or 3, it would disappear. So that's why we put this swap function in here, so the rectangle wouldn't disappear. Because initially, in fact, I think if you look at an early version of the code, the one before this, we have it so the mouse can actually draw a rectangle. So instead of just doing it in code. So anyway.